episode of Finogric machining. We are making one bolt actually. So and also doing some repair work for this lathe. Yeah, repair work. Well, actually what I noticed here is that there is a brake for this cross slide, so it doesn't, you can lock it, and the locking mechanism depends on this little piece, and this one goes under here, under the way, and then we have a bolt like this. It's just the normal M10 bolt, probably original, who knows, and it's sitting here like that. And then you just tighten it, and it will tighten this against, it will tighten and lock the thing, but it doesn't lock. And the reason being is that these ways have been ground, so they are really in a very good condition at the moment, but when they ground those ways, they didn't fix this one, because this is quite precise. It must be so that when it's drawn by the bolt, it will not tilt a lot in any way, and but it's still breaking. So if you look closely enough, so you can see that there is a ledge here on the side, and also this is the braking part here under. That one goes underway, and this is leaning on the cross slide itself, and then the bolt tightens it up. And now when the ways were ground, the entire cross slide went down. Well, I don't know how much, but some amount. But the amount was enough for this not to be any more effective. Yeah, it breaks, but you have to tighten it like a big monkey. And therefore, what we need to do is to take something. I believe I only need to take 0.05 of a millimeter away from this surface, and also from the top of the ledge. Maybe I just file it and test it, because this is actually mild steel. It's not hardened. I tested it. Here is a marking. You probably can see it, maybe. So it's a really soft, surprisingly soft thing. So yeah, and the other thing is the bolt, this one, and this has a hex cap. This is just a normal hex cap screw, and the problem with this one is when you put the compound like this, so you need to have a wrench and put it. It's not very easy to put in there, not at all. And you can tell from the bolt that it hasn't been easy. So this is probably the original solution. Okay. What I will do instead is to make the bolt such that, this is always available in this lathe. This is the Multifix tightening thing. So I make the bolt such that this can be used for tightening the brake as well. I don't know whether this is a good solution, but anyway, when I measured, eyeballed actually, the space here, it's quite enough for this tool to put there, no matter in which position this is, and this is enough to tighten the brake. The leverage is enough there. So now the material. It's this. You probably can see that it's not round. Anybody would, you would probably start with a round stock, but this is tool steel. So it's a little bit tougher than the original bolt, and it's definitely tougher than the mild steel I had there. I have mild steel for this one, but I don't want to use it. This is 16.5 millimeters each direction, and well, this was 16. But the hole here is 17 millimeters, so actually 16.5 millimeters is exactly what I want for the for for this part of the bolt. And then they made this bolt hole really the hole which goes through, which is for this threaded part, it's actually 10.5 millimeters, actually 10.55 I believe, because I tried with my drills, and well, 17 doesn't go there, no, 11 millimeters doesn't go there, 10 millimeters is really sloppy, 10.5 is not tight, but you can wiggle it. So probably I will make this 10.5 millimeters thick from the part that is not having the threads. And then now I'm going to do single point threading with this lathe, because you cannot use a die with this one. You will destroy your die right away. So it will be an exercise. I haven't been doing threads with this one. I measured the pitch of the lathe screw. It's 6 millimeters per revolution. So this means that because this is M10, it's the pitch for that one is 1.5. Now it's exactly divisible by 1.5. 6 is divisible by 1.5. So I can use my half nuts. Yeah. If I wouldn't be able to do that, that would have driven me at least half nuts. So, let's start with making this part suitable for threading and etc. Make it round. I will give you a short presentation. How to set this lathe up for metric gears. Well, the first things first. There are these smaller gears like these two, which one is 28 and the other is 33 teeth. And actually you can read on the table the gear numbers are here quite clearly marked. Actually I am missing 120 teeth gear. I have two couples of 127 teeth gears, but not this 120. But in this case, if we are using the middle, this table and that table, if we are doing metric gears, it doesn't matter, because we are the middle gear, which is the big one. So let me show you the big one. Like this one. So yeah, there is a bayonet behind. There is a door. This one you can open it, and there you have the gears. The main thing was that this was set up for a mixed thing. It had 28 teeth gear here as the first gear, and none of these is for 28 teeth. This one is for 28, but then you are doing, you should have 127 teeth and 120 teeth here. These are working together so that you can do imperial threads. So that was totally wrong. So my first attempt was doomed. Well, it wasn't doomed because I checked this right away. So the correct one for me is either 21 or 33. So I use this 21 because in this table we have a lot more gear pitches to choose from. So in this case, because it was M10, the pitch is 1.5 millimeters. So every revolution is 1.5 millimeters. Yeah. So this means that I need to have the correct gears there. So 21. Then it's irrelevant. I had this 127 teeth gear. It doesn't matter because there is no change in pitch in this case. But then I had have there the 84 teeth gear. Okay. So this was okay. Gears are okay, nice. And then here on the top of the table you can see FR or FZ. This means that I need to have this lever on F position, and this lever must be in either R or Z. So you can make your threads really slowly or decent speed. That's okay. Then that's done. And then the next step is to see that we have, because it's 1.5, we have A selected. It's this lever here. So there is A, B and C. So it must be in position A. Okay, and then when we go down the table, we can see that it's on the 9th line. So the final step is to set this. You first disconnect it, and then you choose from the 10 steps. You, in this case, select number 9, and wait. It doesn't want to go again. There. Now. So you choose number 9 here, and you are ready to go. Well, and I measured the pitch of the lead screw here. Well, that was unnecessary because you can read it here. It's in a very, very small print, but nevertheless it is stated here that the lead screw pitch is 6 millimeters. Good. So now, well, and the thread became quite good. Actually, it was easy to do because I could disconnect the half nuts. There was a problem with half nut because this is really sensitive in a way that when you try to connect it, the nuts will tighten around the lead screw, and even when it's not like engaged into the thread itself, it will try to rotate the lead screw, and now or move the carriage. So you have to be you have to put some counter tension so it wouldn't move itself because this is really it's very light to move. So yeah. So that was one thing that I learned the hard way. And then we have that's it. You of course can select your speeds freely because now the system is such that it first rotates the spindle with whichever system you want, and then it will actually take the threading rotation from spindle. Okay. There is one more thing that you can choose from. It is this lever. It must be in a position you can either use the gears or you can use the belt. And if you are using the belt, you will be getting very lousy threads. So the belt option is really good for feeding because it removes the vibrations. And with the belt system you normally don't use the lead screw. You can actually disconnect it. There is this kind of manual bayonet which you can move like this. This is clutch which you can use to disconnect the lead screw altogether. And then of course you have to choose between left or right-handed threads with this lever. Well, that's about how to configure this for a certain thread pitch. And of course you need to see that the pitch is correct by making you could make a scratch pass like I did, and then with the thread gauge see that it's correct. There is also another way. You could actually rotate this chuck by hand, one rotation, and then measure how much this carriage is moving. Just put the dial there and see that it's moving 1.5 millimeters. There you go. Yeah. So that's one. And what I used was this dial here on this handle. There is also a dial, so I moved it like 10 rounds, and then I checked that it was moving 1.5 centimeters. That's also a way to check it out. Well, I did that check and the scratch pass, both of them. So now, that's how you make the threads for metric threads in this lathe. The imperial threads are about the same. You are just using a different table here, and then you must have this 120 teeth gear there, and also have this 127 teeth gear, and then you can make the imperial threads. Well, I managed to create the thread. Well, let's see how it looks like. This is, please focus. So it became really good. And now we need to do something for this end. Put the hex there. And furthermore, in the final round, I succeeded in this. This is now my threading tool. Well, the tip. It broke off. That material that material is really tough. Yeah, it's tough, and I don't think I need to heat treat on this one. Yeah. So, the thread is quite alright. Goes there, really nicely, like that. And it's not too sloppy either. So, that part success this one. So now the next operations happen in the milling machine. I will take off the nibble, yeah, and then do the hex there. We will be using, I will be using, we will be, okay. Well, okay, so direct indexing will be used to do this one. Okay, passive. So, yeah, okay. So, milling machine it is. To do, I have dialed in this piece, and hopefully it sits tight in the jaws. These are really ratchet, really, they are not exactly smooth, but anyway, it's dialed in, and now what I will do next is to touch the top of this one. Well, no. First I will see how much I need to go in from, because now I faced this one and I have zeroed all my dials here, so I will go 9 millimeters here now. So, well, 9. It's about there. That's 9 millimeters. Using my feeler gauge. So this is something, let's see that it's in the middle about. So 2.13 millimeters from each side. 2.13, okay. This was the 0.1 millimeter we had there, the thickness of the paper, and then 2.1. So this is 1.5, 2, 1, 3, that is 1, and 3, 2 and 3. There you are, locked. Z. Okay. We should be quite ready to go. X-axis is locked, and since this milling machine doesn't have auto feed for Y direction, so I need to do this manually. That's the first flat. Next one will be, I will be turning it, you will see. This is really, so now it's 360, so it should be something like 300 now. That's the place. I'm using direct indexing here, so, and then lock the thing, and then we go. That's our next flat. I'm not using any cutting points on it. go. 180. 120. So I rotate it this way because it minimizes the burr here. Well, yeah. So this way I don't have that much filing to do. Now 60, and this should be our last. Let's see how it fits. Yeah, it's a really good fit. Yeah. Everything is alright here. So I actually did some sandpaper work on it to get really nice surfaces. That's important for the next step, and it also threads in there. I don't want to do this now because it could contaminate with oil from this one. So it also fits in its place really nicely, and furthermore it breaks. So I don't need to modify that piece. I think the original, I don't know whether that is original or not. This bolt actually, well, maybe it's original, maybe not, I don't know. But it had some trouble with it, I don't know what, but this one works way better. And yeah, so the next step is heat treatment. And this is not to achieve strength. Well, maybe I would like to these surfaces here, the hex which is interfacing my tool, to be a little bit hard, so that it doesn't mushroom itself. So for this reason, this is one reason for heat treatment, but the more important is how it will look after that. It will be black. And I like it to be black. Now when I put it there, it will be shining out, standing out from that one, and I don't like that. Black is better. Okay, well, heat treatment, next step. This became a really good looking component. You might notice it's very even in color. Well, there are some key factors when you do things like this, when you want a finish like this. First of all, the original, the surface finish must be good. If it's not good, your blackening will be just making it even worse. So, because the blackening, if the surface finish is not good, this type of blackening will flake off, and you can wipe it easily with a paper towel. This one you cannot. There is some chemical bond with the metal. It must be absolutely clean, and no grease, no nothing, because when you warm it up it will react with the surface. But now when you have just the metal, it behaves like this. And then don't be afraid to warm it quite hot. I believe this is hard now. Not glass hard, but hard enough. I wouldn't like to test it because it's so good looking. But from experience I know that this is now, it's not glass hard, but it's somewhere, well. So, that was one bolt, nothing more. I believe this is a good enhancement for any Weiler which has this type of carriage lock. Because these Weilers originally came with this Multifix tool post, and they all have this type of a key which you use to tighten. So it's always present there. So therefore this is a good one, because now I don't need to have a separate hex key for that one. Yeah, the less tools around, the better. So yeah. So in the next episode of Finno-Ugric machining, what I have noticed here are the wipers for the cross slide and the wipers for the tailstock. These are straight from the 70s. They are made of plastic, which originally was wiping, yeah. But now I can see that there is some black stuff coming out when I move this. So some black stuff is coming out from under. This means that the wiper is not working correctly. And I surely hope that there is no grinding dust or similar under these. Shouldn't be. Maybe some black grease, which would also be a little bit bad. But nevertheless, I will renew those. I will replace the material with this rubber. This is 5 mm thick rubber. The geometry of this is really simple, but this will be in the next episode of Finno-Ugric machining. Till then, bye!